Okay, ladies and gentlemen, I am going to walk you through the review for 6-1 through 6-3. You are still going to be having your quiz tomorrow. It's happening. There's no way around it. And I know that a lot of you feel like you can't learn from a video, but given the circumstances, this is the best I can do for you, okay? So I will post this video walking through most, maybe all, depending on how long the video gets, of the problems. And then I will also photocopy an answer key and post that as well. So you have a lot of resources available to you. There's no reason why you can't get this done. You can ask me questions, you can watch the video, you can check your answers, blah, blah, blah. Look at your notes for the past 3 days. You need to come ready on Friday for your quiz, okay? So, number 1. Find the value of x in each parallelogram. Now this is the directions for all 5 of these on the first page. So looking at number 1 here, we have 2 angles given to us. One is a variable and one is 132. Now these are considered consecutive angles. Remember, consecutive angles share the same side. They're on the same side and they're not opposite or across from each other. They're sort of like right next to each other, kind of like adjacent. So remember, consecutive angles add up to 180. So you've got 132 plus x equals 180, and that's just a matter of subtracting 132. Got my little calculator here. And so x is going to be 48 degrees. Okay, moving on over to number 2. Once again, we are talking about a parallelogram. How do you know? These little arrows, I might not have told you this in class, but these little arrows pointing on the sides here, they signify that these opposite sides are parallel and these opposite sides are parallel. I made cupcakes yesterday. You see the red icing stuck in my nail? My fingers are stained from the dye and the icing. But anyway, okay. I made Christmas cupcakes. Okay, so opposite sides are congruent in parallelograms. So we need to take these 2 expressions and set them equal to each other, and that will allow us to solve for x. So we've got 6x minus 50 equals x plus 25. And at this point, it's just a 2-step equation. We've got to move all of our variables to one side and all of our constants to the other. So subtract x. And we've got 5x minus 50 equals 25. Let's get our constant to the other side. 5x equals 75. And this makes x equal to 15. Okay, so that's number 2. Moving on down to number 3. Also, we are still talking about parallelograms, and in this one, it's not marked the way it was in number 2 with these little arrows, but the directions tell us already that these are parallelograms, so that information is kind of given to you. It's already known, all right? It's obvious. So we need to solve for x in this one. Now there are 2 ways you can handle this. The first way is that these 2 angles, this one and this one, are opposite angles. Opposite means that they're across from each other. So we know that opposite angles in a parallelogram are congruent. So you can take these 2 and set them equal to each other and solve for x. Or the other way that you can handle this is, let me grab a different color. This angle and this angle are consecutive, meaning that they're on the same line, they're on the same side together, and consecutive angles are equal to 180. So to solve it this way, you would add this angle to this angle and set it equal to 180, and that way you could solve for x. X minus 5 plus 2x plus 11, and set it equal to 180. Let's see what I get. This will be 3x plus 6 equals 180. Subtract your 6. 3x equals 174. And 174 divided by 3 is 58. Okay? Okay, and you know what? Now that I'm looking at this problem, this was this problem was created a little poorly, so I must apologize. If there's no way that this x minus 5 is going to be equal to 2x. There's no way. If I found that x is 58, if I plug it in here, that makes this angle 116. And if I plug it in here, it makes it 53. 116 is not going to be equal to 53. So that's not right because opposite angles are supposed to be congruent, and in this case it wouldn't be. So I must have messed up, or whatever teacher created this review assignment must have messed up, because there's no way. And if I were to solve it this way where I set them equal to each other, I end up getting, let me see, 2x equals, subtract the x, you get 1x equals negative 5. So if I get x is equal to negative 5, that makes these negative angle values. I mean, 2 times negative 5 would give me negative 10. You can't have a negative 10 angle measurement. It wouldn't be opened like this. And here, that would also give me a negative 10. You can't have a negative 10 angle measurement. So, like I said, that doesn't seem plausible to me. So I'm going to leave my answer as 58 for right now, okay? And let's move on here to number 4. Number 4, now we have the diagonals of a parallelogram, and we stated that one of our theorems was that these bisect each other. And what happens when it bisects each other is that this side is going to now be congruent to this side, because remember, a bisector means it cuts it in half. So we need to set 4x minus 7 equal to 2x plus 3 and solve. So subtract the 2x and add 7. X is 5. Now, I did skip a bunch of steps. I've been doing all my steps in the other problems, but I think by now you guys should be catching on. And like I said, solving equations like this you've been doing since middle school. So if you need to show all your steps, that's fine. If you understand what I'm doing, if you can follow along, that's great too, okay? Let's move on down. Number 5. We need to solve for, the directions say to just solve for x, but I see 2 variables here. I see a y also. So let's solve for both of them. So we need to set these sides equal to each other, the opposite sides, because our theorem states that opposite sides are congruent. Okay? So we have 3x minus 17 equals x minus 11. You get 2x equals 6. Making x 3. And then for y, let's move over here. We've got y plus 15 equals 3y plus 11. I'm going to subtract my variables to this side because then I won't have a negative variable. So I'm going to go minus y, and I'm going to go minus 11, minus 11. So that gives me 4 equals 2y. Divide by 2. Okay, here's x, here's y. Okay, next page, let's flip on over. Email. All right, number 6. Once again, find all of the variables here. So we've got a parallelogram and 2 diagonals. So as I'm looking at this, there's a couple of things that you need to know to answer this question that come from other previous chapters. So try to think back a little bit. Let's look at, let's start there. Let's start here. Let me grab myself a highlighter. What happens when you have your diagonals is that you end up creating triangles, okay? So here we have a triangle. Here we have another triangle, down here we have a triangle, and up here we have another triangle. So the reason I highlighted this one though is because I want to look here first. Remember back to chapter 4 or 5, I believe, we learned that all of the interior angles of a triangle add up to 180. So we need to add these up and subtract them from 180, and that'll tell us what y is. So basically we've got 82 plus 40 plus y equals 180, because all of them added up together should be equal to 180. 82 and 40 is 122 plus y equals 180. So let's subtract that 122. And we get 58. Okay. Now let's find W and Z. Now, this angle that has a measure of 82, it is across from angle W. So these are called vertical angles. What did we learn about vertical angles? We learned that they're congruent. So W is also going to be 82 then. Okay, 82, let's look at 82 once more. 82 and Z, right next to it, these two angles together create a straight line. Do you see that? So we know that a straight line is equal to 180. So if we've got, I'm going to go over here on the right side, 82 plus Z equals 180. We need to subtract the 180, we need to subtract 82, excuse me, and Z is equal to 98. Okay. And did I have one more? I thought yep, here's an X up here. All right, cool. So remember that in a parallelogram, that means that the opposite sides are parallel, okay? And in one of our previous chapters, we learned that when we have two parallel lines that are cut by a transversal, this diagonal line right here is called our transversal, then it creates some angles that have certain relationships. And one of them was called alternate interior angles, meaning that they are on the inside of the two parallel lines, but they alternate. So here, X alternates with angle 40. These are called the alternate interior angles. And we know that alternate interior angles are congruent, so that makes X also equal to 40. So here's all four of my variables solved. There is a problem almost identical to this on your quiz, so study this one really carefully, okay? Number 7. I'm so sorry that these went through the lines. We have, once again, some diagonals of a parallelogram that bisect each other and meet in the center. So we need to find Z by setting these two equal to each other because they are the two halves of this line. And then we can find Y by setting these two equal to each other. Okay, so let's start with Y. 3Y minus 5 equals Y plus 5. Okay, so I'm going to subtract my Y and add 5, and Y equals 5. Okay, now let's do it for Z. 2Z plus 7 equals Z plus 9. Z equals 2. All right. All I did was subtract Z over here. So I got 2Z minus 1. Z is just a Z. And then subtract 7. 9 minus 7 is 2. All right. Number 8, find X and Y. Once again, we have two parallel lines that are cut by a transversal. So it's kind of like this line here goes on forever, and it cuts through them. And we know that when we have a transversal, the alternate interior angles are equal, so Y is going to be equal to 26. Okay? And then X and 130, those are opposite angles, and opposite angles in a parallelogram are congruent, so that makes X equal to 130. Number 9, find X and Y. Once again, we have opposite angles, and opposite angles are congruent. Okay, so we have 60 equals 10x. To solve for x, we divide by 10, and that gives us 6. To solve for y, we set these two equal now. We have 6y minus 20 equals 4y. And if I move 4y over here with 6, then I also need to move the constant, the negative 20, I got to move it to the other side. So that means I have to add 20. And that comes out to be 2y equals positive 20 because I have to add it to the other side. Divide by 2 gives me 10. All right. This should go by real quick down here. Are the following figures parallelograms? I don't know, let's find out. Number 10 is all kinds of marked up. These little dash marks mean that they are congruent, so these opposite sides are congruent. The double dash lines here mean that these two opposite sides are congruent. Awesome. And then I just told you that the arrows indicate that these are parallel lines. So this figure does meet the qualifications to be a parallelogram, so yes. Remember, look at your notes about our theorems for parallelograms. Okay. Number 11. In number 11, we have two angles that are congruent, and that is noted to us by these double arcs. I call these arc marks. I don't know what else to call them. If you know a better name, let me know. But the double arcs in the corner of these angles mean that they are congruent. Now, these two angles don't have an arc to show congruency, but for example, if these are congruent and these are both, let's say, 50, then if these are consecutive, then this one has to be 130. And if this is consecutive to this, then this also has to be 130. So you could prove that this angle and this angle have to be congruent, all right? So this is good enough for me. I would call this, yes, that is a parallelogram. Okay, and number 12, one of our theorems about parallelograms is that if the diagonals bisect each other, then it would be a parallelogram, and you know that they do bisect each other because of these little, once again, these little slash marks. The single slashes mean that this half and this half over here are congruent to each other, meaning this cuts it in half, this point here. And same thing the other way. These double dash marks mean that this side is congruent to this side because they are cut in half. So once again, yes, parallelogram. All right, last page, we're almost done. Okay, so starting at number 13, this is the material that we learned in 6-1. Okay, so this might be the oldest stuff that you got to think back and remember. Remember in 6-1, I gave you a formula that looked like this, n minus 2 times 180. And I told you that you need to memorize this formula, and I stick with that statement. Memorize this formula. If you don't, you're going to have a real hard time on the quiz, and I'm not giving it to you. Okay? You need to memorize it and know when to use it. Okay? And when you use it is anytime it says sum of the measures of the interior angles. This is what you use to find the sum, meaning add them all up, of the interior angles. So anytime you're asked to add up all of the interior angles, you're going to use this. Okay? So number 13, find the sum of the measures of the interior angles of a decagon. A decagon has 10 sides, and 10 is what n is going to represent. So you're going to take 10 and plug it into this formula where n is, and then just solve, do the math. So we've got 10 minus 2 times 180. So that's going to be 8 times 180, and I don't know that off the top of my head. Give me a second. 180 times 8. 1,440. Whoops, sorry. I didn't realize it was off the screen. Okay, moving down. Number 14 says to find x. Well, we can't just set these two equal to each other like we were on the other page because this is not a parallelogram. Okay, these two sides over here are not congruent and they're not parallel. And these two sides might be parallel, but they're not congruent. So this is not a parallelogram. So we can't just set them equal. This is just a regular quadrilateral. Okay, so you need to first find the measure, or I'm sorry, you need to find the sum of all the interior angles. Okay, so that's going to be this formula again. How do you know what to use for n? Well, n represents how many sides it has. So how many sides do we have in this? 1, 2, 3, 4. So we need to do 4 minus 2 times 180. Okay, so that ends up being 2 times 180, 180 equals 360. Okay, now the reason that this information here is going to be important is because this says that if I were to add up this angle plus this angle plus this angle plus this angle, it has to be equal to 360. And that's what's going to help us solve for x here. All right, so the first one, 110, plus the second angle, x, plus I'm going to go down here to this side. X plus, or I'm sorry, that's a minus. Hold on one second. Sorry. That's what I get for doing my math in pen, right? X minus 15. And then plus the last angle down here, which is 70. And those all need to be equal to 360. Okay, so do you see how you needed to find the sum of all the angles first, and now you can add them all up and set it equal to that? So there's kind of 2 steps involved to solve this one. Combine like terms and solve. We have 110 plus another constant, minus 15. So hold on one second. 110 minus 15, and then plus 70. And we get 165. And let's add up all the x's. We have 1x and another x. So 2x plus 165 equals 360. Okay. Subtract the 165. Is 195. And divided by 2, I'm going to get a decimal. That's okay. X equals 97.5. 97 and a half. Okay. Number 15, solve for x. Now, this time you're not talking about interior angles, so we can't use this formula anymore. Interior angles would be the ones inside, like these 4 that I'm drawing here in red. Okay, we're not given those. These 4 expressions are not inside. They're on the outside. So think back or look at your notes. What do you remember about the sum of all the exterior angles? Remember how I told you that it doesn't matter what kind of shape you have. It could have 5 angles. It could have 34 angles. It could have 1,000,000 angles. All the exterior angles of any polygon are going to add up to 360. Remember we talked about that? So all 4 of these are going to add up to 360. 3x plus 2 plus 2x plus 2x plus 1 plus x plus 5 equals 360. All right, so all I did was add up all 4 angles. Now let's combine like terms. We have 3x and 2x is 5, 7, 8. So that's all the variables. Now let's add up all the constants. We've got 2, 1 is 3, and 5 is 8. Okay, so subtract your 8, 352, and divide by 8, 44. All right. 2 more. Number 16, we need to find x and y. All right, we're going back to the same kind of stuff that was on the first page now. We have a parallelogram, so we know that the opposite angles are congruent. So let's start there. We have 12x, what was I thinking, minus 52 equals 3x plus 2. And solve, so subtract 3, and you've got 9x. And add 52 equals 54. And you get x equal to 6. Okay. Now, how can we find this y? Well, these 2 angles are consecutive. They're on the same side together. They kind of come one after another in a row here, so that means consecutive. We know what x is, so we can stick x in right here. And if we do that, we end up getting 3 times 6, which is 18, plus 2 is 20. So this angle right here is 20 degrees. So we're going to take this plus 20 degrees equal to 180. Okay, so negative 14 plus 20 is 6. And then if you subtract 6, you get y equals 174. All right, and this is our answer. If we take this y and plug it in here, we've got 174 minus 14 makes this 160. And if you wanted to double check and make sure you got everything right, this angle and this angle should be equal to 180, and 160 and 20 is equal to 180. So everything looks good here. Last one at the bottom. Now, in number 18, be real careful with the wording and pay attention to what exactly is being asked of you, because a lot of you are going to look at this and go, oh, interior angle sum theorem or whatever, and you're going to go up here and you're going to look at the formula and you're going to use it and be done. But no, I mean, that's part of it. You do need this, but that's not the only step. There's other things you need to do. That's not what the problem's asking. So find the measure of each interior. Let's start there. Let's stop. Let's stop there and just do this one at a time. Okay, it does say exterior, but we'll get there in a second, okay? So, the measure of each interior angle. The formula up at the top is only going to give you the sum of all of the angles. So, if you want to find what each one is, you got to get the sum of all of them and then divide that by how many angles there are, okay? So, let's use the formula at the top, and we're talking about a hexagon, so that's 6-sided. So you have n minus 2 times 180, and 6 minus 2 times 180. So that's 4 times 180, and I don't know, I need my calculator. 720. Okay? Now, this is the sum of all of them, so if you were to add them all up, if you want to find what each one individually is, you got to divide it by how many angles there are. If it's 6-sided, it's also 6-angled. Is angled a word? I don't know. So we need to take 720 and divide it by 6. So each angle is 120 degrees. Okay? Each. Okay. And then we need to know each exterior angle, all right, of a hexagon. Remember, no matter what kind of shape it is, hexagon, heptagon, dodecagon, whatever, they are all going to have exterior angle sum of 360. So if all of the exterior angles added up together is 360, you need to take 360 and divide it by how many angles there are, and that'll tell you what each one is, okay? In a hexagon, there are 6 angles and 6 sides. So 360 divided by 6 is going to give you 60, okay? So in this problem, each interior angle is 120 and each exterior angle is 60, okay? Be really careful with this one. There is a problem exactly like this, you know, just with different numbers, on your quiz. So like I said, be careful. All right, and it looks like that's it. That's the last one. So if you have this done, great. Get it turned in when you come to class tomorrow. I won't be here. There's going to be a sub administering your quiz. And when you're done with the quiz, there will probably be a short assignment for you to do and get turned in. Okay, so I will see you guys on Monday. Have a good weekend. On Monday and Tuesday, I know a lot of you are going to feel like you don't need to come to school because, well, Wednesday, Thursday, Friday, you're off. So a lot of you are going to try to take that extended week. And I mean, I don't want to say that's fine, because it's not fine to just ditch school, but if that's what you choose to do, then that's what you choose to do. But I want you to realize that we are still learning things on Monday and Tuesday. Just because you decide not to come to school doesn't mean that the whole world stops, okay? So we're going to be doing 6.4 on Monday and Tuesday. So if you don't show up, you're going to miss that whole section. And then probably going to struggle on the test. And it's the last test of the semester. So it can really make or break some grades in this room. Just want you to realize that, okay? So have a good weekend, guys, and I'll see you Monday.